Hi, my name is Yushan and I'm from 5 Science 2. My physics teacher is Puan Hazura. Today I would like to present my physics chapter 1 PL6, which is force and motion. So we are doing the question analysis now. My question is taken from the 21st Century Challenge section, which is in my physics textbook, page 37. The question is, Figure 8 shows an iron plate on the floor of a warehouse. The iron plate is supported by a system of springs below it. The system of springs is capable of supporting a maximum load of 3,600 kg with a compression of 5 cm. Figure 9, which is bottom here, shows two types of spring that can be used. You are given the task of suggesting a suitable design for the system of springs to support the iron plate. Your suggestion should consider the following aspects: the type of spring used, the number of springs used, the position of each spring. Justify the design that you have suggested. Gravitational acceleration g equals to 9.81. Now, here's the calculation. Basically, the first thing we have to count is the maximum weight of the load, which is 3,600 times 9.81. What we got is 35316 Newton. Now, let the number of springs be arranged in parallel below the iron plate equals to n. The compression of each spring, which is F, equals to 35316 over n. From the formula that we learned in chapter 1, which is this chapter, is F equals to K times X. K means spring constant, X is the compression of spring. So based on the formula, we will got that 35316 over n equals to Kx. And now we are going to find the X, so we just move the X in front and the 35316 behind, which is n equals to 35316 over Kx. So now we will compare the two springs with substitution. Now we will take the formula that we calculated just now, which is this, n equals to 35316 over Kx into the spring X. So just sub what we got at the question there. K equals to 800 Newton and X equals to 5. So this is what we got. So what we got is 8.829. Basically, we have to count how many springs they are using. So we have to round off the number, which is equals to 9. Now we do the same thing to the spring Y. Just sub that K equals to 1,800 and X equals to 5 into the formula we got. So what we got from spring Y equals to 3.924, which after round off is 4. As a conclusion, the maximum load will produce a compression of 5 cm when 9 springs X are arranged in parallel or 4 springs Y are arranged in parallel. So now, I would like to talk about the suggested design of spring system, which in the second slide we got said that I need to decide. A. The type of spring used. The type of spring that I chose to use is spring X. This is because spring X has a smaller spring constant, which means that more spring X are required. When the number of springs increases, this means that the compression forces that acting on the spring can be reduced. Now, we are looking at the number of springs used. As what we had calculated just now, 9 spring X are arranged in parallel below the iron plate. So, from the statement of the conclusion we got just now, the maximum load is divided into 9 smaller components that are 4,000 Newton on each spring. Lastly, the position of each spring. So this is how I arrange the 9 spring X on the diagram that I have shown here. This is what I drawn just now, and The spring will be arranged following the number 1, 2, 3, 4, 5, 6, 7, and 8, 9. The uniform arrangement at here ensures that the iron plate is supported in a balanced and stable condition, because you can see every edge have springs and even the middle also have a spring. That's all for my presentation. Thank you so much for watching.